Good afternoon. This is Schweitzer, and we're going to run through a little bit of, do you need help with the math on our label for our calorimetry lab? Now, we'd like you to be able to do this on your own. So, what are we asking you to do? And then maybe you can try it on your own, and we'll give you. I'm not going to do any math on here. I'm just going to explain things, and I think at that point you should be able to do this. All right. So first of all, I'm trying to get to from what I have, all right, to calories per serving. Calories per serving. Now, we're just trying to make, the reason why I'm going to calories per serving is so that I can compare apples to apples. I wouldn't want to compare calories per gram to calories per serving. I could convert, this guy here, this is the calories per serving. I could convert that to calories per gram, and I could compare my experimental data in calories per gram to this guy. We want to make sure we're comparing the same values. So the question is, how do I get my experimental data from what I have from the lab to the calories per serving? All right, so first of all, the lab takes, it's just a quick, you know, look at the lab here. We take a can of water and our collector, and we took a Cheeto or some food item, and we impaled it and burned it up here. All the heat goes up. So first of all, we want to figure out Q. Q is the amount of energy that the water gained, and it's also energy that, well, technically it came from the Cheeto. All right. So we're going to use the water as our collector. Q equals mass times change in temperature times specific heat. All right, so next, I could have burned several different Cheetos. You got long Cheetos, you got bent Cheetos, right? Stubby Cheetos. They're all the difference. Maybe at the bottom of the barrel, the bag, and you got little, stubs. You're getting the bottom, but the crumbs. So not every Cheeto is created equally. So we're gonna try and have a ratio of energy per something, technically a serving is a mass. So we're going to do a ratio per mass of Cheeto per mass. So divide the two and you get a ratio, and that ratio should be the same whether you have a big Cheeto, fat Cheeto, or broken stubby nut crumb of a Cheeto. Same ratio. So the energy is going to go in here, and the mass of the Cheeto is the mass burned. We don't want to use part of the Cheeto that's not burned. So make sure you're subtracting your two masses so that you have, you're just taking the ratio per burned Cheeto. I did not include the weight of the paperclip sticky, either. So this is going to give me joules per gram. So now the rest of it is literally just conversions to get to from here joules per gram to calories per serving. Now on this guy, make sure mass is the mass of the water above. This is the change in temperature of the water, and this is specific heat of water. If you're really stuck on this, then you got to back up and watch some videos on that. But so now I want to get rid of these units and get to these units. So joules will have to. I'm just going to show this. Joules needs to go to calories. You should be able to convert that. And then calories actually needs to go to commercial calories. All right. How many joules are in a calorie? Well, there's 4.18 joules in 1 calorie, and there's 1,000 chemical calories in 1 commercial calorie. So that's the conversion rate between these things. And I'm not going to walk through the factor label. You can set up your units and cancel them out. The grams needs to be converted to grams to servings. Okay. And what is that? Now, this is not the packaging from our lab. I'm not going to do that on here. I just downloaded one of these. But you got to look at it and say, okay, where on the package can I find that? Well, this one says right here about 55 grams per serving. So that's the version here, 55 grams to 1 serving. So then I'm going to have calories per serving, which is really calories per 55 grams in this example. You need to go on your own label in the lab and look and record down your own information on this. Okay, and make sure you include this in. Now, I mean, what I've discussed here would be fine for maybe highlighting the calculations in the conclusion, but otherwise you can include these calculations in your lab report and calculations there, and make sure that you answer any questions if there are any. Thank you very much. Should be it. Now, one last thing here is percent error. Okay, so if you don't know what percent error is, you got to go and you got to look it up. Okay, so percent error is going to deal with a couple of things. There are 2 values. Okay, there is your accepted value. Now, your accepted value is literally what's on the package. Okay, and then there's the experimental value. That is what you got in your experiment, would be right from your lab, and then your calories per serving that you got for yours. Okay, now those are 2 things you need to solve the percent error problem. If you don't know the percent error formula, do a quick Google search and you'll find it. I'm not going to give it to you. Now, last thing is does my answer make sense? Does my experiment, there might be lots of error. You know, is there a reason for a high percent error? And that's something that you likely could discuss in your conclusion. So with that being said, you know, I think if you have a situation where you're losing a lot of energy, ask yourself this question: does all the energy actually go in the cup? And think about that for a little bit and say, does that make sense? Okay. And that's all I'm going to add in for this video. Thank you.